So let me start with the case study here. This is actually one of the case study in operating system, that is case study report on sleeping barber problem. So let me show the image first. We already know what is barber, how a barber shop will be. Customer will be entering here, and there will be chairs waiting. Might be customers will be there, or they may not be there. And inside, one customer is engaging, and another customer is leaving. So what it compares with the operating system is it defines about the synchronization process. So we already know what is synchronization process. The condition here is no two processes can access the same shared data and resources. So it is a critical part of the operating system to decide what to do. As it has to ensure that process can safely share resources without interfering with each other. We should not disturb each other. So to achieve process synchronization, we use this techniques. Various techniques can be used. One of the technique is called as the sleeping barber's problem. So that's what I have explained here. Here the problem here is in sleeping barber problem. Imagine we have a barber shop with a single barber and a limited number of chairs for waiting customers to sit. So when the barber is free, he will sleep. If a customer arrives, he sits at the chair that is available first, then the barber cuts his hair. The remaining customer has to wait at the waiting chair until the barber finishes cutting the hair of preceding customer. However, if all chairs are occupied, when a new customer arrives, the new customer leaves the shop because there is no place to wait itself. So here the sleeping barber problem, which represents the several challenges, such as what are all the challenges like resource management, that is efficiently managing the limited resource, that is chairs and the barber, to prevent deadlock and ensure maximum utilization. And one more thing is synchronization, where it coordinates the action of customers and the barber to avoid race around conditions and ensure orderly processing. And we have customer handling arriving customers appropriately by either assigning them a chair or asking them to return later if the chair is not available. So these are all the several challenges in this problem we have to face. To address these challenges, we are just going to apply synchronization mechanism like we have semaphores or muters locks. So what is semaphores here? If we consider as semaphores, we can apply it for chairs. We use semaphores to represent the available chairs here. The initial value of it is set to the number of chairs in the barber shop. We know semaphores can handle the value as zeros and ones. And if you take mutex lock to consider it as a barber, a mutex lock which ensures that only one customer engages and interacts with the barber at a time to prevent race around condition. In mutex lock, no two process can enter the critical section. This we already know. And the next one is conditional waiting. When a customer arrives, they have to check if there are any chairs available to sit or to wait. So the chair semaphore count is decremented and they wait for the barber. If not, they have to leave. Okay, barber's actions. That is the last challenge. The barber he will checks for the waiting customer. If there are any, they cut their hair. If not, the barber sleep until a customer arrives. So this is the challenges. So in this implementation part, each customer and the barber are represented as a separate thread. So this synchronization mechanism which ensures proper coordination and resource management. Customers wait for the barber if needed and the barber serves them in an orderly manner. So if not, they have to rest. So let me start here. This is the normal flow chart. Sleeping, if sleeping, it's a closing time. And waiting customer, cutting hair, and closing time, he can go home. And cutting hair, if there is no customer, he will just go back to sleep. So this is the conclusion here. This problem shows the challenges of resource management and synchronization of process in operating system. So by this, using semaphore and mutex locks and semaphores, we can devise a good solution to ensure smooth operation and maximize the resource utilization. So this case study will helps the illustrate the importance of these concepts in real world applications. Thank you.